Okay, so let's look at this problem. This is really sort of the big calculation skill for this section. Okay, so you've got this rational function. You know, another way to look at the function is to try and factor it. So the big idea is you're changing the way you're getting an equivalent version of the function where maybe something happened. And so I factored, and I notice that this reduces. So all this would be true. We're just getting another version of the function. Okay, now let's see. Where would it be interesting? Where should x head to? Well, we can look at the end behaviors. And that would be x goes to plus infinity, or x goes to negative infinity. There's one choice, okay? And we also want to look at where is the output of the function not defined. So in this case, polynomials are defined everywhere. We just can't divide by 0. And so the places we want to look at are where x is worth -1, because it's the first one, or x is worth +1. How can we pick those? Because f of -1 doesn't exist, and f of 1 doesn't exist. Okay, so the end behaviors, since it's a rational, let's say the limit as x approaches infinity, or x approaches negative infinity. Let's just call this f of x. F of x would be equal to the ratio of the leading terms, which is worth 1. And so what does that tell me? Remember, the 3 dots mean therefore. Therefore, we have a horizontal asymptote. End behavior equal constant gives us a horizontal asymptote. Okay? Okay, now let's look at this point. Let's see what happens. F of -1 doesn't exist, but if I put it in the reduced function, it does exist. So you're like, bam, I'm going to get a numeric limit. Okay, so the limit as x approaches -1 of f of x, we're going to just put it in the reduced function. And we're going to get a number. Okay, so it's -1 plus 2 over -1 minus 1. I think that's 1 over -2. So -1/2. Okay. Okay, so what does this mean graphically? It means that we've got a removable discontinuity at x equals -1. You think the point -1, -1/2 is going to be on the graph, but it just isn't there. Okay, now our third thing to look at was +1, and the reduced function does not exist. So you're like, bam, we can't get the reduced function. So we're going to look at it both ways. The limit as x approaches 1 from the right, and the limit as x approaches 1 from the left. Okay, so let's see. We would have 1 plus 2, because we only really have to adjust for the pluses and minuses from the left and right if we're close to 0. If you want to make it more concrete, this is like 1.001. And you're like, if I take this number -1, I get a super little positive number close to 0. So that's 3 over 0 plus. That's one of our basic forms. That number is positive, so it's going to explode up. Okay. If you did from the other side, you get 3. This number would be like, if you're at 1, you're coming from this side, that's like 0.999. So if you take that number, subtract 1, you get a really tiny, tiny little negative number. So this is going to be a negative number, and it's going to explode. So this is negative infinity. And then we know we have a vertical asymptote of x equals, and where did that happen at? That happened at 1. Versus this one's a horizontal asymptote.